Hi guys, welcome to the last segment of our lesson. So guys, we've been busy with some compound growth and also we've been busy with some nominal and effective interest rate. So let's just do a quick recap and then do some questions to put everything that we've done so far into perspective. So let's just do that. Now remember, our big idea is finance. We looked at what growth and then simple interest and compound interest. We also looked at DK, which was in two branches, straight line and reducing balance. Now, the main idea right now that we've been looking at for this particular lesson has been compound interest. Now, let's look at this question and just see if we can then answer this and make whatever that we've done so far to have some substance to it. It says Kian invested an amount of, so this was an investment of an amount of money 10 years ago. What amount did he invest if the investment is now worth 150,000, right? Now the interest that this guy got is constant at 6% per annum compounded quarterly. Now, if we look at what we are doing here, what they are saying is 10 years ago, there was an investment that Kian actually opened, right? And then he invested, let's say, an X amount of money, which we really don't know for now. But the investment grew and it became 150,000 in 10 years at a constant interest rate of 6% compounded quarterly. So what they want us to actually find was the principal amount that Kian actually did invest 10 years ago. So let's see what exactly this means. Now, we start with our data. We know that the value of A is 150,000 and the value of P is the unknown. The value of I is 6% quarterly. Now, I am emphasizing quarterly here because you need to take into consideration how it is compounded when you start calculating. And then the duration was for 10 years, and the 10 years was also quarterly. Now, we know that if it was compounded quarterly, it means I'm going to divide by 4 there, and here I'm going to multiply by 4. So the calculation will then be A is equals to P, open bracket 1 plus I to the exponent of N. My A is 150,000, so let me just erase that. This is 150,000, 150,000 is equals to P, that's what we're looking for. I know I said he invested an X amount of money, but you must not substitute X here, please. You leave it as P because it represents a principal amount. 1 plus the interest was 6%, so it's 0.06, and this was compounded quarterly to the exponent of the 10 multiplied by the 4. Okay, let's go to our calculator and see what this will be. So firstly, I know I have 150,000 and I'm going to divide this by the whole bracket that I have there, which will be 1 plus a fraction 0.06, 06 divided by 4, because it's compounded quarterly, to the exponent of 10 multiplied by 4 is actually going to be 40. And then I want to find what the answer is. So it means Kian actually invested 82,689, right? So the value of P is 82,689. Let me just verify that. 689, yes, and 35 cents. 689 and 35 cents. All right, so you will then conclude, therefore, Kian invested 82,689 and 35 cents. The second question, Lebo invests 50,000. Now, we need to know what is the interest rate per annum if Lebo's investment is now worth 80,000 after 6 years of investing, the interest is compounded, right? So the interest is compounded, but they are not specifying how compounded it is. So we're just going to take it as it's just compounded per annum, meaning yearly. So we're not going to change anything there. And then if I calculate this, remember the formula first. A is equals to P1 plus I to the exponent of n. My A I know is 80,000 because that's what it was worth after 6 years. And Lebu actually invested 50,000. And this was at an interest of I, which we do not know, but this investment was for 6 years. Now we go back to our calculator. I have 80,000. I'm going to divide this by the 50,000 there, which will give me 8,5, 8 over 5, I mean. So this will be 8 over 5 is equals to 1 plus I to the exponent of 6. Then from there, remember, you're going to take the 6th root on both sides. So this will mean I'm going to take the cube root, but remove the 3 and put a 6 there into the 8 over 5. And that gives me 1,081 and a few decimals. Then from there, I'm going to subtract 1 on both sides, which will give me that. So it means that Lebu's interest rate that she actually got from the bank was 8,15%. So I is equals to 8,15%. Now, if we get to this, what I want you guys to please note here is, please understand that when you're doing financial math, you only round off when you get to the final answer. So you saw that as I am busy calculating, there were decimals that I was getting, but I was avoiding writing it down. So I was just using the calculator and saying answer, answer. So that's one of the ways that you can do this, because as soon as you round off, in the midst of you calculating, it makes the final answer to be incorrect with a few decimals or a few rands. So in financial math, we only round off when we get to the final answer. Throughout the calculation, you use the decimals as you are getting them. Let's look at one more question. Now, the question, Sarah invests the amount of 5,000 that she got for her birthday. The bank decides to say, we're going to offer you an interest rate of 4.5% per annum, compounded monthly. That is very important. Remember that we're going to look at compounded monthly. And then after 3 years, she then decides to make another deposit to her investment, and the interest then changes to 6.1% per annum. Now it changes to, not that it becomes 6.1% more. So it just became 2, something or 1, something percent more than what she got for the previous years. And this is actually compounded semi-annually. So please look at that. After another 2 years, she then also adds 2.5 rands to her account. So this was supposed to be her there. So this is her account. And what I want you to then know about this is how much will she then have after 8 years if the interest rate is 5% compounded weekly during the last year. Remember when we started, I said there will be a time where they just become a bit funky about what we are doing, and now they are asking us about compounded weekly. Now, in this particular example that I have here, guys, this is when we then introduce what we call a number line, right? Or a timeline. A timeline will be what helps you to show when money came in, when money went out, and also the change in interest rates, as you can see here that for the first 3 years, the interest was 4.5. But after that, the interest then became 6.1. And then later on, the interest also changed and it became a compounded weekly. So you need to then use a number line, which will be what will assist you in trying to do this correctly. Let's look at what the number line will look like. Now, if I draw my number line, right, so what I know here is at T0, T0 will represent when the investment started. You're going to draw an arrow that goes inwards, right? The arrow that goes inwards shows that it was a deposit that was made. And this deposit was 5,000. And then from there it says the bank offered her that interest rate, but after 3 years, meaning at now T3, right? She then also continued to add another amount in her bank account, which was 8,000 rand. And then this interest rate then became 6.1%, compounded semi-annual. After 2 years, so after the 2 years now, after 2 years it means it's actually T5 because T3 plus 2 years will give us the T5. She then also added another 2,500. So this was 2,500. But the investment actually remained there for 8 years, right? And they're saying, we want to know what is it that Sarah actually got after the 8 years. I'm going to also include the interest rate there so that you can see what it looks like. For the first 3 years, the interest was 4.5%, and this was on a monthly basis because this was compounded monthly. And then for the 2 years, the interest became 6.1%, and this was on a semi-annually basis. Semi-annually basis. Remember also the other word for semi-annually is the same as half-yearly. And then for the last duration of her investment, it actually now became the 5% compounded weekly, right? So this was on a weekly basis. And then you will then use all of this to try and calculate this. But now let's go back and analyze whether we actually included everything on this particular timeline. The 5,000 is there, we included it. The bank offered her 4.5, we did include it. This was for 3 years. She then decided to add that amount, which we included. The interest actually changed to 6.1%, which we did include. Now they're saying after 2 years, she then added the 2,500, we've shown that, to her investment. Remember, that is her. And then how much will her investment also be? So that's supposed to be her worth after 8 years if the interest is 5%. So I'm thinking the 5% is not actually going to be from T5 to T8, you see. So you will also need to look at that. It means that the 5% will only be between T7 and T8. That's where the 5% will be. But between the T3 and T7, her interest rate was actually still 6.1%. So let's just fix that quickly. So from there up until T7, her interest was that. And then you will use compound interest formula to find the first portion, second portion, and the last portion. And then add all of them together, and that will give you what this was worth. So I know that this is something that I want you to be thinking about, because now I've scaffolded the question for you. I want you to think deeply about it and try to do it. In our next lesson, we're going to dive deep into number patterns or number lines and do exactly what is it that this question wanted you to do. So let's just recap quickly of what is it that we've done so far. Now, what we've done so far is with compound interest, the time period for earning interest is very important. There's a time period for compounding, and also you always need to add an increased amount of interest to the total at the end of each period. and this takes on an exponential growth. Guys, we've looked at finance and we've looked at two concepts under growth. We've looked at one concept under decay. We are yet to look at the reducing balance. And that's it from me. Guys, until I see you next time, cheers.